All right. So, welcome again, everyone, to the Blind Spot podcast. And of course, we are playing like many kinds of triples and doubles. And last week or last time, you had Adam and Evan, and today you have Evan and Marcelo. And I think we've done all the possible combinations already because I had an Adam and Marcelo before.
That's right.
So we exhausted the doubles.
That's right.
Today is the last one. And then, eventually when we pick up again, we are going to have also guests, as we've been
Yeah.
saying, but not doing. But our plan is to actually have different kinds of guests here. And we'll do that just to liven up and diversify our portfolio of people that we engage with directly, right?
Right.
And so we're talking about what to discuss today. And because I have a very heavyweight philosopher here, and I think it's super important to do this, is a word that physicists they do it, but they don't really know what they're doing, and it's confusing. And I would love for us to expand on this notion of ontology. And the plan that we have more or less is to give a brief history of ontology as we move forward in our journey of understanding what is the world made of. So I think, Evan, will be really good for people, for me too, actually, to hear from you a little bit of what is the definition or definitions of ontology.
Yeah. Well, the way that people, or let's say philosophers, usually use the word conventionally today is ontology is the study of what exists, but in a way that's not maybe the best way to think about what ontology is, because if we think of the words ontos and logos, ontos is the Greek word for being, and logos is, of course, the word for logic or reason or word. So if we wanted to be a little bit more faithful to the Greek, we would actually say that it's the discourse about being. And then what has happened, so here I'm actually making a point that Martin Heidegger makes, what has happened in the history of at least Western philosophy in ontology is that it has tended to understand the question about what is being in terms of what kinds of beings are there, what are the existence or the what's the fundamental stuff, or what are the entities that make up the universe. And that way of talking goes back, of course, to the pre-socratics. And I know you, Marcelo, have a particular love for the pre-socratics. So why don't you tell us something about your love for the pre-socratics?
Yeah, so it's true. I mean, I confess my sins. I think every book that I have written has something about the pre-Socratics in it. I always find a way to kind of bring them in because, to me, just a little bit of the history of philosophy, right? There is a turning point, sort of like this new axial age that happened in the 6th century or so BCE, right? Where in Europe, the things were happening in India, of course, with the Buddha, in China with Confucius and Lao Tzu. And then in Greece, in Europe, you had this, well, what people call the beginnings of Western philosophy, right? And I'm always worried about the word beginnings because it's beginnings as long as we know it, because it could have, it could have had other people. Like Homer was 2 centuries before, I think, the pre-Socratic. So stuff was going on in Greece that we don't really have documentation from. And in fact, one thing about the pre-Socratic, so pre-Socrates, right? And which means there is a before Socrates and an after Socrates. And if you look at all of them, the different schools of pre-Socratic philosophers, the last one that people talk about, which actually for physics is super important, which is the atomists, right? They actually overlapped and they were more or less Democritus and Leucippus were kind of around, certainly Democritus around Socrates' time. So it's pre-ish Socrates in a sense. But from what I remember, what distinguishes them is that they were a turning point in the way people ask questions about the natural world. What is the world? And mostly on the methodology of the answer, because before or still with them around the same time, people would use more mythical explanations to describe natural phenomena, right? So one of the typical ones is why does the sun go around from east to west every day? And then the answer would be something like, oh, because the god Helios in his golden fiery carriage carries the sun across the skies every day and repeats their motion. So that is a mythic explanation for a natural phenomenon. And what these guys would do is say, well, what if we don't invoke the gods directly, which is, it wasn't that clear cut, but directly to explain things and use our reason and also observation to kind of intuit a little bit what the world was like. So it was about reason more than myth as an explanation for what was going on. Is that more or less
Yeah, I
okay?
mean, I think that's usually the way the story is told. I think it's easy for us to tell it that way retrospectively because, we sort of sit where we are now in history and we look back and we think, oh, there's, a mythic form of understanding, and then there's this what we now today would call a scientific form of understanding. I think it's a lot less clear cut in the ancient Greek world. But of course, that said, there is obviously this recognizable change in discourse where you have an idea of say nature and the way that one could pose a question about nature as such, nature as a whole, and pose it in a way where you're seeking some unifying fundamental understanding. So Thales will say, everything is water, or Heraclitus will say all is fire. So you get the idea of appealing to something that is evident in our concrete experience of the natural world, and that would somehow be deeper and more unifying, and that wouldn't be personified at any rate, if you want to put it that way, in terms of divinities or gods. Though, of course, you have the divinity discourse going on in parallel. And even somebody, I think Heraclitus says this, everything is full of divinities or everything is full of gods. I think
No,
Heraclitus,
it's
if I remember.
Thales said.
Sorry, right. Thales says that. Yeah, you're right. It's been a long time since I read the pre-socratics. Actually, I should say, just this is a kind of interesting autobiographical side note, is that when I was a teenager, I studied classical Greek, and I got really fascinated by the pre-socratics. You could, I bought this book in a bookstore in New York City. You could get Kirk and Raven's The Pre-Socratic
You
Philosophers.
got Kirk and Raven.
I
That's
just
how I
walked
got
into a
into it too.
bookstore. Yeah, I
Oh
walked into
wow,
the 8th
that's
Street
wild.
bookstore in New York City. There it was sitting on the shelf, pulled it out, and I was studying Greek, and it has the Greek text,
It
which is hard to
does.
read. And so I could make out some words and figure some things out. So I just got completely, I was about maybe 15 at the time, drawn into the world of like ancient Greek thinking. And it was through that book. Yeah. Through the pre-Socratic philosophers, Kirk and
That is
Raven.
awesome because same book,
Okay.
Kirk
Yeah.
and Raven,
Yeah.
and my older brother had this book all, underlined and highlighted in yellow and stuff like that. And when I was about 16 or so, 17, he said, Marcelo, you're interested in science and philosophy, read this. And and so he gave me the book, which I still have this
Yeah.
book,
Yeah. I
all
still
these
have
years.
mine too. Yeah.
I
Yeah.
love this book. And there
Oh, it's a beautiful
was a
book.
new edition after that, and now there are others, but exactly, they had the Greek text and the fragments, the original fragments that
Right.
could be
That's right.
found, right? Because
That's
one
right.
of the things about the pre-Socratics that people should know is that most of what they wrote disappeared, right? I mean, for Thales, there's nothing. There's just apocryphal stuff. But
Right.
for Heraclitus, there is stuff, which is the fragments. And for Anaximander,
Yeah.
who is my favorite of them all, is there is like one or two sentences that he has written, and that's it. Everything else came afterwards, mostly from Aristotle, like 300 years after these guys, writing about them to criticize their ideas. So,
Exactly. That's right.
right?
That's right.
But
Yeah.
that's so
That the other
funny.
book I got at exactly the same time that I reread and we cite in the blind spot is R.G. Collingwood's book, The Idea of
The
Nature.
idea of
And he
nature.
starts with the pre-Socratics. And he makes this really interesting point. He says, there are the pre-Socratics who talk about stuff like water or fire. And then there's Pythagoras, who talks about pattern, who sees that, you can have different things that nonetheless embody or exemplify the same pattern. And of course, he's thinking about like musical intervals and, on the lyre. So you have like the strings that vibrate, but then you have the patterns, which have a different kind of intelligibility or level of understanding to them. And of course, that's mathematics, right? And so when that flows into Plato, you get this idea of mathematical understanding. And Plato actually will think of the fundamental constituents, going back to ontology, he'll think of them as actually mathematical entities. He'll think of them as, so we have the Platonic solids, the geometric figures, and the idea that nature is somehow composed out of these. So the most fundamental ontological understanding, in the sense of understanding of things and how to characterize them, for Plato, actually mathematics enters into, center stage.
Yeah. And so these guys, it's good that you mentioned Pythagoras, but the other ones, Thales and Heraclitus and these guys, their fundamental question was, what is the world made of? What is the stuff of the world, right? Which is an ontological question. How do you describe what's out there, the being, the stuff? And it's funny because if you ask a modern high-energy particle physicist, so what do you do? Oh, I'm trying to figure out what is the world made of.
Right.
So, right? So 26 centuries later, here we are, right? We're figuring or trying to figure out what the world is made of. And this is kind of like the narrative that we encounter, at least Evan, myself, and Adam, when we're discussing science in general, right? Which is, we ask the same question, but the way we answer that question changes in time. And so if you think of it as, in this very narrow word definition of ontology, like what is the stuff of the world, the fundamental substrate of reality, so to speak, right? A physicist would answer it differently depending when you're asking that question, right? So Newton had a different answer, even around the Newtonian time. If you had Newton and Laplace, right, jumping a little bit. So Newton would say everything's made of atoms. He was an atomist, big time, right? And Laplace was not. He was, not Laplace. I mean Descartes.
Descartes, yeah.
Yeah, so I'm talking still 17th century. So Descartes would say, no, you have a plenum. Everything's filled with stuff, which is more of an Aristotelian notion, right? Because those first, there is a sort of a hierarchy of stuff. So the first pre-Socratics talk about the fundamental element of reality. Everything is water. And then people say, well, that's so ridiculous. What do you mean by everything is water, right? I mean, if you think of it with the modern mind, and I tell my students, look, you can't, you're not being scientific about this. You're being metaphorical about what is reality for them. And one of the beautiful things for us, for me, on the pre-Socratic, especially these earlier schools, is that they were describing nature mostly as being always in a state of flux, a state of becoming, right? So you always had this tension between being that which does not change and becoming that which is always in the state of flux. And those guys, Thales, Anaximander, Anaximenes, who actually proposed air as the fundamental one.
Air,
and then Heraclitus proposed fire. So, he ran out of elements like that.
Of course, don't forget love and strife in Empedocles. That's a bit more mythic.
Yes, that's true. And was it Empedocles that came up with the 4 fundamental elements of reality? Right. I think he was, right? So he had these 4 things. And then, as you mentioned, love and strife as the forces.
Exactly.
This is really, really cool, right? The forces that bring this stuff together or separate them is love and strife.
Love and strife,
It's kind of like physics. And no wonder they were called the physicists, right, in the early days, right? Because they are trying to, look, there is stuff attracts, stuff repels, and that's what we see in our everyday world. So they're building this kind of like narrative, which we're still using, obviously, in different ways in physics, but it really is the fundamental building blocks of what we call modern science. It's all starting there. And you mentioned Pythagoras, so it's cool because I think he is contemporaneous with Thales and those guys around 600.
600 600s, I guess. I think his dates are 7th century, 6th century BCE. Yeah,
But in
yeah,
a completely different, so these guys, Thales, etc., they were in Miletus, which is now the western coast of Turkey. And I think Pythagoras was in the southern Italy, right? It was in
yes, Samos. I think.
Samos, yeah.
Yeah, yeah.
No, Pythagoras of Samos. I think he was. Now I'm confused. I think he was born there, but I think
That's right. But that's right. Yeah,
his commune was in
yeah.
Croton in southern
Crouton,
Italy. So
that's right. Yeah, yeah. In southern Italy. That's right. Yeah, he had this community of disciples, I suppose you could say. That's right.
it's Lindisfarne, like
That's right. I know. My dad would actually say that. He would actually, he invoked
really.
Pythagoras a lot. He did. Yeah, yeah,
Because
yeah.
for those of you who did not watch our previous episode, that's when Evan talks a lot about how he grew up in this intellectual community called Lindisfarne that was founded by his father, and it was a wonderful initiative that we're trying to emulate very humbly in Tuscany with the Island of Knowledge,
Right.
right? But in a sense, Pythagoras was doing that too, right? With his
Absolutely. Yeah, that's right.
and it was very good. Like there were men and women with equal rights.
That's right.
They were
Vegetarian. He didn't believe in eating
vegetarians.
meat. Yep.
Yeah.
Yeah.
They also didn't
And
eat beans for some reason.
that's right.
And it was all about this encounter with divine, which was an abstract mathematician, right?
Yeah.
So for them, the communion with nature was through the mind of this mathematical creator. So the more you understood patterns, geometry, that's where it comes, right? I mean, the whole notion of triangles and squares as sort of the fundamental building blocks of everything.
Yes. So when you get, to Galileo and the idea that, the book of nature is to be read in the language of mathematics, I mean, that of course goes back to Pythagoras, that idea.
And I mean, they launched, because it's so interesting, because they were at about the same time, but they were really interested in developing mathematical descriptions of nature. I mean, it was very different from the guys in Miletus, who were just more like the intuitive physicist kind of thing, so it's all water. Why? Well, because water flows and the cosmos is an organism,
Right.
and water sustains and and fire transforms, and these guys were in a completely different vibe.
Yeah.
Right?
Yeah.
It must have been a wild, wild place.
Yeah. Yeah. So that idea that the cosmos is an organism, that's something that Collingwood emphasizes a lot in his book, The Idea of Nature. He says if we really want to get inside the Greek way of looking at nature or understanding nature, we really have to shed our habitual kind of mechanical ways of thinking that we have had since the rise of early modern science, and we have to really think of a way of understanding and experiencing the world as if it were a living being, as if it were a living organism. And the shift from the Greek, let's say, into the early modern, with of course the Middle Ages straddling the two. In Collingwood's narrative, that's very much a shift from the world as fundamentally alive and living. Even when Aristotle talks about the movement of the spheres, he's not thinking of it as a machine. He's thinking of it as this kind of living, animated cosmos. The shift from that into a mechanistic understanding that we really get with Galileo and Descartes, of course, and obviously with Newton, that's this really fundamental change in, you might even say, in kind of the backdrop to ontology, in the sense of ontology that concerns like what kinds of things they are and how they behave, because the background, assumption isn't really the right word, but the background setting for the Greek view is this cosmos is alive. And the background setting for, the modern version of atomism is no, it's a machine. And, life is sort of a secondary derivative epiphenomenal process.
Isn't that funny that you were saying that? And I was thinking, that sounds so like our ancestral knowledge that the world was alive.
Right.
And,
Yeah.
very similar, right? And you have that in Japan too, with the Shinto and all that, this notion that there is this vibrating energy that is some sort of connecting, the universe and everything in the universe. And these Greeks, just like if you ask a Native American, they'll say, of course the world is alive. If you ask a
Yeah.
Native Brazilian, they say that all the time.
I would say it's only our so-called, modern Western scientific culture that thinks of it as not alive. And actually, the anthropologist Marshall Solins has a book about this, published, I think, after he died. And I'm forgetting the title, but the basic premise of the book is that the way that we look at the world, you might say mechanistically, is despite its obvious power and influence, it's just historically and anthropologically a completely outlying, unusual view. That's not how most human beings through most of history have understood the world and their relationship to it.
Isn't it? Let's kind of improvise and go a little deeper into this stuff,
Yeah.
because to me that's really fascinating. What the heck happened, right?
Mm-hmm.
In Europe in particular, which is, at least to me, is closer to, you may want to say that in Asia, for example, it never really changed that much, but in Europe it really did change, right? I mean, there was a shift. And here's my guess, okay, and see if I'm completely off or not, see what you think. My guess is that it changed when monotheism took hold of intellectual life as well, not just spiritual life, but intellectual life. Because there was a departure that happened there, in the sense that as monotheistic beliefs became more kind of cemented, the gods left the world and went up to the skies, so to speak, right? God went from being something that was gods, well, all over the place. There was almost no separation between us and the world of the spirits. No wonder Thales would say everything is full of gods. He was referring to magnetic forces. Why some rocks are magnetic or not? How could two pieces of rock, which are not alive, have a force? I mean,
Yeah.
what the heck is that about? So there must be some sort of a alive thing in that, which was magnetism. And he used that image to describe it. But eventually, when the gods left, rocks just became rocks, and there was and the world just became, even though there is life in the world, it became sort of like, it lost its soul, so to speak, because all the souls went up to the heavens.
Mm-hmm.
And I wonder if that has something to do with that, because when you talk about Galileo and Descartes, certainly, but most of all Newton, he's talking about a designer God that was
Yeah.
very much the Christian God, that was very much an ideal creator more than anything else. So he was a theist, in a sense that God created, who was also present in the world, but more as an intellectual presence than as although he he says that it was God that pushed the moon around the earth or the planets around the sun and stuff like that. What do you think of this?
Well, I think that story is actually a bit more complicated. So I think that when we get to Newton, and already in some ways in Descartes, and certainly by the time we get to Darwin and English theology, the idea of God that really has taken over is the demiurgos idea of
Yeah,
God. It's
the
it's
deist
God
God.
is the deism, yeah, the designer God. If you conceptualize the universe as a machine, or on analogy with the machine, then the role for God is to stand outside and be the designer or the maker. But I don't really think that's the conception of God. That's not the only conception of God in monotheism by any means, actually. So I would say that, in medieval philosophy, whether Christian or Islamic, God is not a demiurge. God is a grounding principle of all being. God is being with a capital B, if you will, and is the necessary source of any contingent limited being. And that's not a demiurge conception of God.
Right.
That's a conception that allows for the world of nature still to be ensouled, if you will, in the
Yeah.
in the ancient Greek sense. So I think it's, this is pretty clear in Descartes when he basically says to the church, you can have the soul and the mind, but give me the physical universe. And it works mechanistically. And that's because, the laws are those that, God set up. And I mean, we have that already in Plato with the demiurge conception, but it's not the sort of, if by monotheism we mean, one absolute source of everything that also at least traditionally, would be personal. You can have a personal relationship to it. That's not a demiurge God. So I think we need the demiurge God to get that de-souling of nature going.
Right. So would you say that for, until the Renaissance, then maybe was this kind of God was part of the ontology?
Right.
Could you say that? I think you could say that, right? It wasn't just stuff. The stuff was
Right.
God.
So I mean, exactly. This is in a way what Heidegger calls ontotheology, is that you, on the one hand, you have this idea that there are beings, and beings are to be understood as, or being is to be understood in terms of the entities that are, and then the supreme entity is God. So you conceptualize God as if it were another entity, but that's
Yeah.
actually, and so he calls that ontotheology, but that's actually, I think, from a really deep monotheistic perspective, that's a distorted understanding of God, because God is not a being. God is being with the capital B, and is the ground and source. And so the minute you make God into a being, then you I think have actually not, in some sense, according to those ways of thinking about God, you haven't really understood actually what God fundamentally is.
Right. So God transcends prepositions, right?
Yeah,
God is not a anything,
that's right.
right?
Right. So God is not a proper name in that sense. It's not the
Right.
name of an entity, if you will.
And then what about, I mean, you're talking about Heidelberg, 20th century, but, Leibniz would come up with a whole, through, I think, ontological description with his monads of God
Absolutely.
in this stuff, right? God was part of the stuff through these. Do you want to mention that? Because he is, at the same time as Newton, and
Yeah.
he's thinking about it in a much more active presence than Newton is, which is more of like a cosmic.
Yeah. I mean, Leibniz has an amazing, complicated, rich philosophy where, reality fundamentally are these transcendental noumenal entities that he calls monads. So monads aren't like physical atoms, because they're actually transcendental and noumenal. They're not phenomenal. So they're not given to our, ordinary sense perception. And he works out a view of the monads through kind of, you could say, logical metaphysical argumentation. And of course, God is still, in some sense, a designer, or has a designing power, you might say, because God is the architect of all of this for Leibniz. But the one thing that, that's interesting about Leibniz, or one thing that's interesting about Leibniz in relationship to things we see in contemporary discussions of, science and cosmology, of course, is that, Leibniz asked this question, why is there something rather than nothing?
The question, right?
The
Yeah.
question, right? And many, certainly not you, but many physicists think that science, that is physics today, has basically answered the question, or there's nothing left over to the question once we give the scientific narrative. But that's a
Yeah.
profound misunderstanding of what Leibniz was asking, because, Leibniz was asking, or included in Leibniz's question, is why are the laws of nature the way they are? They might have been otherwise. They're contingent. So you can't invoke the laws of nature to explain why there is something rather than nothing, because the laws of nature are themselves contingent. And what Leibniz is asking for is something that has a necessity that underpins contingency. And of course,
Yeah.
no scientific narrative can really give you that. No cosmological narrative can give you that. It's not in the nature of science to do that. Science shouldn't try to do that. It's not the business of science. And I mean, that's a part of our argument in the blind spot, right? Is exactly that.
Yeah, unfortunately, in fact, my answer to that question, science cannot even begin to understand that, because it's, as you just said, I think it's important to emphasize that science was not designed to answer these kind of questions. This does not belong into the methodology of science. I mean, you
Right.
cannot create an experiment to describe why the universe, why is there something rather than nothing? I mean, don't even know how to do that. So it's not an
Exactly.
empirical question.
Yeah, and that's no criticism of science. It's a
No.
criticism of people who say things about science, some of whom are sometimes scientists, who are getting science wrong, actually. And
Yeah.
that's so important to understand.
Right. And I would say, oh, no, for example, the way scientists will answer that, and we touched upon this a little bit here, would be through, well, in the beginning, there was some cosmic bubble that, expands, or or there is before the Big Bang, there was another phase, pre-Big Bang
Right.
cosmology.
Right.
And how do you model that? Oh, well, we model that with, a field, and it has to conserve energy and it has to interact this way or that way. I said, but wait a second. Where does the conservation of energy, the fields, the way you describe this interaction, where does this model come from?
Exactly.
And you cannot get away from that, right? So it
Absolutely.
is, because it's sort of, you cannot build a building without materials. And
Right.
science is the same way, right? You're building a narrative about the world, and the materials are the conceptual structure, and the ontological framework. What is the stuff that I'm going to use to build the world? So the pre-socratics, oh, it's water, it's fire. And now we're talking about quarks and leptons, which are the particles of the standard model of particle physics, with the Higgs there too. And what's interesting to me is that you can never be sure that your current ontological description of the world, what is the world made of, the stuff, is the final answer, right? And we spent some time discussing that, right? Because there's always room for discovery, and well, maybe the Higgs is not a fundamental particle. Maybe there is a fifth force of nature that is holding the bits of the Higgs together, and that would change your ontology again, because it's not four forces. We always talk about the four. So for those of you who can remember, gravitational force, electromagnetic force, and then the weak and strong nuclear forces. These are the ways in which we describe the material world now, according to high energy physics, according to these four forces. But that does not mean that we exhausted our understanding of the world of the very small to say, this is the way the world is made of, folks. And if we create a theory that brings all these four forces into one, our monotheistic theory of everything, then we're done, right?
Right.
And we're never done.
Yeah, never done. And indeed, it doesn't, in some sense, at least to me, really make sense to think that we could ever be done, given
Yes.
how science works as a human enterprise. We human beings have a particular way of being in the world. Science is this social activity that requires an incredible infrastructure. And what would it mean to finish the activity of science and to have a final theory, a theory of everything, in a sense where everything doesn't mean just we unify things that we don't know how to unify today, but in some sense it would be comprehensive, so that we would be able to describe and understand anything that we encounter in the cosmos in terms of it. That strikes me as one, just not inductively true in terms of how science historically works, but two, I'm not even sure I know how to make sense of that as like something that could possibly be, or something to strive for.
Yeah. And I think that's a little bit Plato's fault, or at least the way Plato is understood, or how he percolated through the history of
Right.
knowledge,
Right.
with this notion that there is a blueprint of reality which is accessible by the human mind, right? This notion. And that's what captivates lots of pure mathematicians, for example, right? I mean, I've had a lot of conversations with pure mathematicians whom I greatly admire, but there is a bit of a religious twist to this stuff. It's crypto religious, because they really feel, especially even Gödel, that nature is fundamentally mathematical, right? That it is the blueprint. So if you talk about ontology here, it is a bunch of mathematical laws, right? That will describe everything. And our job is to figure those out. And that knowledge is absolute.
Right.
It's not human. Meaning, if you have another kind of intelligence that understands counting, that intelligence will also
Arrive at
apparently
the same thing. Yeah.
the same laws, because they are universal, they are unchangeable. And I don't get that, at all. And I wonder how you have thought about,
Yeah, I feel the same way. I mean, on the one hand, I think there's a beauty to the idea, and I understand why someone would find it beautiful and would want to participate in the project of uncovering that. I mean, that psychologically doesn't seem strange to me, but it seems to me you have to take yourself out of the activity in order to really understand what that could possibly be. But in taking yourself out of the activity, you've removed, well, not only the source of it, but you've actually removed something that you would need to understand as part of the narrative. And the only way to do that is in this self-involving, reflexive way where you're always changing because you're investigating yourself. So
Right.
that, the minute you start thinking of it that way, it doesn't really hold up. It doesn't really make sense, at least to me.
Yeah. It's a little bit like a priesthood, because you'd say,
Yeah.
look, there is this God-given beauty that is really, it's completely mathematical out there in the world, right?
Right.
And we are the ones that have limited but some access to this beauty, and we are the translators of this God-given, don't need to call God, but it could be something like a demiurge or whatever, some designer that is a purely mathematical being. And then we understand some of that, understanding the mind of God. This is a metaphor that has been prevalent. Even Stephen Hawking, who was the
Yeah.
opposite, comes and uses that idea that the mind of God is the way the world was created or conceived, and the job of the pure mathematician or the theoretical physicist is to kind of unveil that
Hmm.
blueprint for the rest of us. So we are the prophets, we have the divine kind of understanding of this stuff, which I think is a little crazy, honestly. But when I was in my 20s, that's why I went into string theory, because
Sure.
I'm like,
Yeah.
how could I not? I mean, if you are romantic, right, how could you not go into that kind of stuff, right?
Yeah. That's what I mean by it has a strong aesthetic character and aesthetic pull. And many people get drawn into math and science through that, or philosophy too, in certain respects, certain kinds of philosophy anyway. But I think once you start plumbing the depths of what I would call the mystery, it becomes apparent that it can't really quite be like that.
Hmm.
Because I mean, the way that I think of it is that your own being, your own consciousness, your own experience, your own ability to understand mathematical intelligibility principles, whatever, that's something that you always have to, in a sense, bracket and put to the side when you sort of externalize this vision of a mathematical universe or a mathematical cosmos. But it gets thrown back at you, as we talk about in the blind spot, whether it's through in logic through Gödel's theorem, or in quantum mechanics through the observer, or the limits when we go to infinite values in cosmology, whatever it is, it gets thrown back at you that, well, you actually can't take yourself out. And the minute then you realize that you're in, well, then you have a real mystery that isn't amenable to the same kind of explanatory method. That's how I see it.
Right, right. That makes sense. And it has a lot to do with this. You can't solve this question ever. The idea is math invented or, discovered, right?
Right.
Which is this whole, discovered would mean, yeah, it's out there. We just pluck at this or that, and invented meaning we're just making this up to make sense of reality. And I'm very much an invented kind of guy. Like
Mm-hmm.
we are creating a narrative which is quantitative to make sense of what we can measure of the world, right? And it percolates into physics and say, and it's true. It's what confuses people, right? And me included, and I guess everyone, is that when you look at the history of physics in particular, there were certain kinds of mathematics that, first of all, were invented by pure mathematicians and then were co-opted to explain things in physics. And they work incredibly well. I mean, we talked about this before. I think Einstein used it to
Mm-hmm.
describe gravity in his general theory of relativity. He needed geometry in curved spaces, which he didn't understand. But all these fellows, Gauss and Riemann, and they all had discovered these things by playing with what would happen if I draw a circle, triangle on a ball as opposed to on a flat paper. Oh, wait, the laws, change because the sum of the angle is not 180 degrees anymore. It'll be bigger if you're doing this on the surface of a ball. So there is this non-flat geometry that is exactly what Einstein was saying. How is that possible, And the other one, which is truly beautiful, in my opinion, is when Dirac, in 1929, Paul Dirac, brilliant theoretical physicist from Cambridge, he says, there is a new theory of the atom, which is this quantum mechanics theory, which describes the wave equation. Schrödinger describing how an electron goes around a proton in a hydrogen atom really well, right? It can jump from different levels of energy, etc. And it says, but this electron is moving really fast around the proton. So I need to include Einstein's theory of special relativity because the speeds are not at or close speed of light, but close enough that I have to find corrections. So This guy creates this beautiful new kind of quantum mechanics, which is relativistic quantum mechanics now. And all he's done is expanded the original notion that was the theory that Schrödinger discovered mostly to include motions at high speeds, including the electron. And when he goes to solve his new equation, he finds there are two solutions. One is the electron, a particle with a negative charge. And then there is a twin particle, just like the electron, but with a positive charge. He says, there are two solutions. What the heck is this? So initially he said, maybe this theory is really telling me about the electron and the proton, but they have different masses. It was a little bit of a confusion until people realized that no, what you're doing is the mathematics predicts the existence of a new particle, which is an electron with a positive charge, which we call a positron. And lo and behold, a few years later, boom, they find the freaking positron.
Yeah.
So the mathematics, bringing these two seemingly very different theories together, allowed for a guy to predict the existence of something in the world, a new participant in the ontological framework of reality, right? This new thing, just without seeing it before.
Yeah.
And that's what drives people like, wow, this is just amazing, right?
Absolutely.
And the same with Einstein, he did that with his theory of relativity, general theory. Says, well, if space is curved, then all these different things are going to happen.
Yeah.
Right? Gravitational waves are going to be there. And then he didn't like it, but then people said black holes are going to be there. And you go and you look for these things and bingo, there they were.
Right.
So that's what makes this so kind of, it's almost disconcerting, right? So how the heck could math know?
Well, I mean, that's where I think neither the discovery nor the invention alternatives in that dichotomy probably are the right way to think about it. Because, I mean, clearly in some sense, math is an invention, but it's an invention that allows us to make discoveries. And, in Whitehead's language, it gives us this kind of like foothold on the mountain as we're exploring things. And the foothold's real. I mean, there are many possible footholds, and if you have different sized feet, you're going to have different sized footholds. And it's like, this is sort of the perspectival view in philosophy of science, right? Is that there's different perspectives with different models, with different assumptions, with different tools, and the good ones all do fasten on to something, but that doesn't mean that they're all going to come together in one unified thing.
Right. Yeah. And the other argument that people use sort of to go beyond this kind of awe-inspiring thing is to say that, you could invent all sorts of mathematics. You could describe a geometry in 10 dimensions, in 20 dimensions, in 100 dimensions. You could write the equations for all of that. That doesn't mean it exists.
Right.
So we are very selective. We are picking the mathematics that actually works for the world in which we exist, the world we interact with, right? So that we have this kind of like, I am in this world, I perceive this kind of reality, and this is the mathematics I'm going to use to describe this kind of reality.
Right, right. Well, and we do that, going back to ontology and Aristotle, in philosophy, we, since Aristotle, have worked with, the absolute inviolable bedrock of the principle of non-contradiction. And we, don't allow for systems of reasoning or logical formalisms to have contradictions, because if you have a contradiction in classical logic, then boom, you can derive any proposition, and then you're stuck with this explosion, as it's called. But through advances in computing and in the study of self-reference and recursivity, reflexivity, and also in metaphysics, it turns out that we can devise very useful logical systems that are non-classical, that don't abide by the principle of non-contradiction, that turn out to be very useful in computing in some contexts, and in the context of metaphysics, allow for, this would be the idea of what in philosophy is called dialetheism, to introduce another Greek word, that allow for the possibility of true contradictions. That is, the idea that there could be contradictory, you might say, states of affairs that arise at certain limits. So the philosopher who's really worked a lot on this is Graham Priest. So if people are interested in following up on this, check out his work. But the idea is, in his way of articulating it, is that when we sort of stretch our thinking to certain limits, we arrive at certain limits of thought, we hit things that are contradictory, but there's a truth to the contradiction. There's if you say something like reality is ultimately ineffable, well, that's contradictory because you just said something descriptively about reality, namely that it can't be described. So what do you do with a contradiction like that? It's at the limit of your trying to characterize a totality, reality. So you hit these limits. Are they just limits of thought, or are they actually limits in the nature of things? This is a complicated metaphysical question, but it shows that even things that we take as really fundamental, like the principle of non-contradiction, well, they're up for grabs too, actually. And that's pretty wild.
Yeah, it's true. And, in physics, at least, we always deal with this in terms of when the mathematics fails, the physics is in trouble, so to speak, right? So we describe everything in terms of equations and mathematics, and, sometimes the solutions to these equations, they are inconsistent. And what do we mean by inconsistent? What the heck does that mean? Well, they violate either a certain law of nature, and so we discard them, or they arrive at a singularity, right? Which we discussed before, which is basically when you divide things by zero and you get infinity. And I agree with Graham there, because even if you apply this to the beginning of everything, right? To say, look, you can do this mathematically. You can take the limit of the radius of the universe going to zero. You're going to get all sorts of weird stuff when that happens, but that is telling you something new. And it's telling you that you need to think beyond this framework in order to make sense of what's going on. Right.
Yeah.
So in that sense, I get it. It really is almost like a portal to, this is messed up. Let's try to do. The only problem, though, is that if you get stuck on the power of the formalism as a way to tell you the truth about something, then you may never get out, and then you get stuck.
Then you get stuck.
And that's what the loop of within the blind spot. You just get in there, and you're just like a chicken without a head, and you're just keeping going around in circles, and that's worrisome. And that's probably what a lot of so-called problems in modern science that we talked about, that try to get to this absolute knowledge of things, fail. The program failed, right?
Right.
I think Isaiah Berlin said something about this. He said something about criticizing absolute knowledge. He said something like, any absolute knowledge is nonsense because it assumes that it starts from nowhere, right? And the point that it has so every knowledge that makes sense to us human must be relative knowledge. It can't be absolute knowledge. You have to compare it to something, right?
Yeah.
And whenever science starts to make absolute statements, it is just nonsense, right?
Yeah.
And that's what we're guarding against. That's
exactly.
Right.
Yeah, and it's important just to reiterate, it's not science itself that makes these statements. It's scientists who go beyond what they should say on the basis of what the science is actually about.
Right. And that's why scientists should learn more philosophy. I think it will be very useful. useful,
Yeah.
for a lot of scientists to do this, because honestly, it kind of allows you to get out of this kind of vicious circle that sometimes we find ourselves in, right? And some
Yeah.
people spend decades of their lives in that situation, and then they go, "Oh my goodness, I was looking at the wrong place," or "This idea is wrong. I could have abandoned it many years ago." And that to me is another topic that we discussed a little bit, is that when do you declare an idea wrong, right?
Yeah. That's a complicated one.
Super
Yep.
difficult. And that goes on to the ontology description again, because you can say, for example, in string theory, they were proposing, and we have to wrap this up soon, but they were proposing a radical ontological shift in the stuff of the world by saying it's not point particles anymore,
Right.
the atoms of reality. It's little vibrating tubes of energy
Right.
as your fundamental stuff, right?
Right.
That's very deep, and it would have been profound if we were right, but it does not look like it's right, at least from what we can say, at this point, and it's been a long time. And
Yeah.
so the question is, what do we do now? Are we ontologically stuck?
Yeah.
Because point particle is also a mistake, because a point
Yeah.
has no volume. And how can something that doesn't exist have physical properties like mass, particles? So these are all images that we use. And then people say, well, it's not really point particles, it's fields, and fields are spread in space. And what is a particle? A particle is a lump of that field. Well, it's a lump, but does the lump have no volume? And so you start to kind of get into sort of games where the mathematics is actually clearer than the words. To me, this is all pointing to what you said before, the mystery, and the mystery of not knowing what's around us. And guess who has this awesome statement about mysteries? Democritus, one of our first atomists. He
Right.
said something like, in reality, we know nothing because truth is in the abyss.
Yep. There you
So
go.
there we go, right? So we're full circle back to this guy saying, yeah, we've learned a hell of a lot about the world. But the point is that there's always going to be something else to learn as long as we are looking. We can look, and we get grants to look, which in these days get a little complicated here in
That's
the
gotten a
US.
little bit more fraught, but yes.
So let's make sure that this goes away soon. Well, all right. I think we did it.
Yeah,
It
we
went
did.
fast.
Good one. Yeah.
Yeah, it went super fast. And
Yeah.
we're not quite sure what's happening next. We're going to discuss. If you have
Yeah.
suggestions, for those of you who stayed with us all this time, ontological ride, thank you so much. And we'll see you soon on our next The Blind Spot episode.
Yes. Thank you. See you soon.